join them here for so I work at introduction. My name is Duc Ba. I am PhD candidate at Nguyen National University. Today I am very happy for stay here and tell with you some interesting data about detection of CHF3 in an atmospheric plasma system. Today I would like to tell with you several sessions. The first is introduction of greenhouse gas and detection of CHF3 and objects my study. And second part I will show experiment and then in my present on focus in effect of ambient environment on the detection of CHF3 in an atmospheric plasma system, and then at the end I will show some pointers in my presentation. Now I am going to session 1. Here so we schematic of energy exchange between solar and Earth surface and atmospheric. Here you can see when daylight is solar radical can be absorbed by surface of Earth and atmosphere, and then Earth surface emits radical thermal. In this case, larger amount thermal radical from surface can be absorbed by atmosphere. After that, the atmosphere emits thermal infrared radical to the Earth's surface again, and in space. Therefore, when increasing of concentration of greenhouse gas, increasing temperature in the world. Greenhouse gas is generation from nature process or human activity in, for example, decomposition of organic material or burning fossil fuel and agriculture, and several industry process generation greenhouse gas. In figure, so the emission of carbon dioxide increasing while in forest area degree from 1904 to 2015. It presents us increasing of emission greenhouse gas a series of situation of the world. In this picture, show what kind of industry generation high greenhouse gas and what gas generation in industry. Here you can see energy industry maybe contain about 60% of total greenhouse gas in the world, and carbon dioxide is the main greenhouse gas. It contains about 80% of total greenhouse gas over the world. Here you can see SFC and PFC and SFC about 6%, but CHF3 is a product during manufacture of CHF22, but for fluoride carbon compound contain about 6% of emission of total greenhouse gas, but global warming potential of CHF3 higher than carbon dioxide about 11,700 times, and lifetime of CHF3 about 260 years. So that's decomposition of CHF3 to other chemical is very important and interesting for the reduce greenhouse gas. Now today we have thermal oxidation and catalyst and plasma rejection are for the decomposition of CHF3. In thermal oxidation is high operation temperature about 1200 Celsius, and this process requires other for treatment exhaust gas. Example, in this process, merge treatment SF acid and HCl acid. But in this thermal oxidation, higher of rejection CHF3. For catalyst methods, related low temperature about 500 Celsius. But in this catalyst methods, SF acid formation reacts of catalyst. So that is this main problem of catalyst methods. In plasma rejection of CHF3 is this reaction can be performed at low temperature and fast and high conversion and easy control. Why plasma rejection can be do this reason with easy? Because the key of rejection of CHF3 by plasma is by electron impact reaction. Here I show several main reason of electron with CHF3 in a plasma system. Electron high energy can be generation under electrical field. So that's the reason can be performed at room temperature, faster and easy control process. However, in plasma method, low flow gas and low energy efficiency. So that's in my object, I want to improve energy efficiency for reduction of CHF3. Here is a object of my study. Reduction of CHF3 were performed in an atmospheric plasma. The plasma is quasi recharged immersed in electrical insulator oil. And also the reason performed in the same reactor, but reactor is exposed in air for comparison ambient environment affected on the reduction of CHF3 in the atmospheric plasma. Now I want to show what I did. Here is the mixed gas from CHF3 and nitrogen and oxygen, with the ratio of nitrogen per oxygen equal 79 per 21, and then introduce discharge zone by MFC. MFC is mass flow rate controller, and then for generation electrical field, I using an LP plasma power supply. For record electric waveform, I using regulator oscilloscope, and for analysis of gas product, I using DC system, and then for analysis optical emission of plasma, I using one system records OES, and in the reader have a discharge gap about 1 millimeter, and discharge volume is equal 10 milliliters. For understand my work, you can see schematic of my experiment. For detection of CHF3, I perform two cases. The first reactor in air and second reactor in oil. With variation voltage and CHF3 concentration and frequency of power, and then I compare temperature breather and power, and then conversion of CHF3 and SCNE selectivity product for 2K collision. Now I would like to turn to research section. Here I would like to show a temperature breather according to reaction time and absorption voltage. Is fixed on the left is surface temperature as a function of time reaction and absorption voltage, and fixed we show a power as a function of time reaction and absorption voltage. Here you can see power and temperature is linear increasing with toward of time reaction and voltage. However, in this case, you see in with absorption voltage of 7 kV for inert. This non-line because we have a peak at reaction time 9 minutes. And with temperature about 350 Celsius. Here question, why is this guy 7 kV we have a peak at 9 minutes? I would like you attend to next slide. This show you why is this for reason. Here in fixed A, so we cross my reactor. Here this I have a three layer dielectrics. The first is gas gap layer, and second is small oil or gap, and at the end is dielectric discharge layer. Because in reactor it causes so that is capacitance of layer can be giving this function, and then here you can see a layout of circuit reactor in a series of capacitance. Here is for capacitance of dielectric discharge, and for gap of oil or air, and for discharge gap, and so that's a series, so that is capacitance total can be generated by this function, but small gap of air or oil is very small, so that this part can be 10 to 0, so that we have a C total equal 1 per Cg plus 1 Cd, so that is power of discharge can be given by this function. And here you can see is this part your function of Rg. This form of mass is A Rg plus 1 B Rg. What is this function? Here you can see this function can be addressed minimum as Az according to our experiment, it may be obtain minimum at 350 Celsius. So that's it. Az FAZ mean at this point, and then so that's a power obtain highest at Az about 350 Celsius. Here I want to show the effect of absorption voltage on the conversion and selectivity product. You can see in figure A composition of CHF3 increasing with toward of voltage, and however in this case the same for chain of selectivity of carbon dioxide and carbon monoxide. For explain this results by from the increasing power in the air. However, in this case, when you can see a 7 kilovolt, a composition of CFT and under oil or air is the same about near 100%, but power of in the oil is lower than in the air, so that's is present that a energy efficiency in the oil is higher than in the air. Here I would like to show the effect of concentration of CFT. In this session, we consider range of CFT from 5% to 15%. In this case, in the oil, composition of CFT reduce toward with increasing of concentration. But in this case, almost I can obtain the composition of CFT more than 95%. For the same chain of CO and carbon dioxide, however, in this case, selectivity of byproduct of carbon dioxide in oil higher than in air. For effect of frequency, we consider from 10 to 30 kHz. For the same chain, in this case, because when increasing of frequency, macro discharge increasing, so that's increasing of conversion of CFT from 10 to 30. For the same above results, in high power, the selectivity of carbon dioxide is higher than oil at the same application voltage. And for analysis plasma system, we are using emission spectrum of CH3 and nitrogen and oxygen in plasma. Here you can see in the spectrum we have detect several species of nitrogen oxide and nitrogen and CF2 and CF and CO and CO2 and hydrogen and F. This can be helpful for analysis mechanism of plasma reaction. I would like to make several points as follow here. In plasma, performer in air is higher than that in oil, and this can be explained by degree of resistance of plasma toward increasing temperature, and the reason in oil is increasing power efficiency and high conversion of CHF3 and high selectivity of major product. And one reason for important is when reactor in oil is high stable, and so that's the rejection of CFT in oil is high performer for rejection of CFT. However, in our research, gas product content of NO, so that in future I will consider rejection of CFT in catalyst and plasma reaction. We hope a remove of nitrous oxide in product. My presentation size several data here, and thank you for attention. I would like to answer have a question if you have.